My name is David. Our project is prototype for TG table, which can be used in changing beats or changing songs. Our project has two ultrasonic sensors. Each sensor has its own out.
So as David was previously saying, the project is mainly based on two ultrasonic sensors. I'll be telling you what the first sensor does. So the first sensor is basically responsible for turning on the LEDs and adding beats to the song. So when an object is in the minimum range of the sensor, the first LED will be turned on and the first beat will be added to the song. When the object starts gradually going out in the range of the sensor, it will add more beats and more LEDs will be turned on. And now Omar Sharif will be telling you what the second sensor is supposed to do.
ثلاثة.
I will continue off from where Anas left us. So basically, the second sensor is the sensor responsible for the volume. Um, as the object approaches the sensor, the volume increases, and as the object goes away further, the volume decreases.
My name is Yahya. Let me explain the hardware connections we've got. First, we have a serial to USB converter to connect the Altera board to the laptop that will play the sound files. It will send the input from the Altera board into the laptop, and how it will be handled will be explained later by my colleagues. Second, we have two sensors that we tried separating them away from each other as far as possible to avoid interference between the sensors. And the LEDs were added to help us realize what level are we at to make the coding easier.
Hello everyone, my name is Asa.
And my name is Omar Hussein, and we have been working on the most of the programming for our project. Okay, now I'll explain to you how our ultrasonic sensor works. First of all, we provide it with a high voltage for the trig input for 10 microseconds. Then we anticipate the echo to start calculating the distance of the object above it. Okay.
Okay, now how this is done is using a Verilog. Okay. First of all we will send the trigger for 10 microseconds. Okay, let me find it. Okay, over here. 10 microseconds is about 500 clock cycles. Okay, which is why we will assume that the trigger output is 1 for 10 microseconds. That's enough time for the sensor to send its signal. Okay, and after the 500 microseconds are over, we start anticipating the echo for what is almost 2 milliseconds, which is more than enough time for which is more than enough time for us to for it to travel to and from the object above it. Okay.
Okay. And after that time, we reset everything. So we can start resending sonic pulses to detect any object above the ultrasonic sensors. And then here we in our module, in the same module, we have two always blocks, one for this sensor and the other for and another one for this sensor. Basically, each one will set different values, different variables to be different registers to be true, and the combinations of the value of of the distance obtained at this sensor and the distance obtained at this sensor will send data as we will continue.
Okay, now how do we communicate between the sensors and the computer? We use the RS232 port to USB converter. This allows us to send bits of data from the Altera, which we've collected from using the sensors, and send it to Java. in order to use it to calculate the distances between the sensor and the object in question. Okay, so before we start on the Java code, I need to explain what kind of data we send using the RS-232, and Omar will explain this for you now.
Okay, so the kind of data we send through our serial cable or the RS-232 is basically characters, and each character is dependent on the distances obtained from both sensors. Okay, and now talking about the Java code, here we use two libraries, one called the GNU and the other one called the RxTX API. They enable us to listen to the serial port, to the serial communication from the Altera, and read the data. And with this data, we can start our music player.
Show you the Java code which establishes the communication between the Altera and the laptop. So here we create the class communicator2, which implements serial port event listener, and here is the method which sends characters when the object approaches the sensor, so that the beat will be added according to this according to the distance. The beat will be added or subtracted from. According to the character, which depends on the distance between the sensor and the object, we will add beats, remove beats, stop or play, pause or play.
And now I'll show you a demonstration of the program. Okay, first we should start it on Java. It starts with the normal song. Okay, I will demonstrate the pause and resuming features. Pausing depends on the distance. Before I say anything, it only calculates the distance when I press this button. Okay. Now, if I press this button while I'm far away from the second sensor, it should pause the music. Since it senses that there's an object within kind of far reach from it, it paused the music. Okay, and to resume it, I just have to get near to it, like so. Okay. Now, okay, so for the part that makes this DJ project, depending on my distance from this sensor, I should add certain level of beats to the music. Okay, starting from this approximate level. Not this one. Okay, I'm pressing the wrong button. Okay, this is the first beat added. Okay. Now to add the second one, okay, this is from the medium range, and now for the farthest range possible. Okay. Yeah, as you can see, as you can hear, the three levels of beats are now added. Okay, now I can pause and resume just as much as I want, or I can change the beats however I want. Like so. Just skip the first one or add the second one.
Conclusion, as you have seen, we were able to use the distances obtained from ultrasonic sensors to send data to our computer, and according to this data, we were able to mimic a DJ by changing beats or playing and pausing the music. Thank you very much. That's it.